Hi, my name is Pedro and this is on my function. In this video, I'm going to show you a problem that is very niched, but if you have it, it's going to be very good to watch this one. Let's imagine that you have an app that consumes a WebSocket that has many updates per second. So let's say that the WebSocket connection pushes an object, and every time that this object comes in, you need to transform this object into something else. When this happens, the main thread gets blocked because the WebSocket is handled on a main thread. The way to handle that while keeping the 60 FPS that you want for your application is transferring this formatting, this transformation of data into outside of the main thread into the web worker. In this way, you can keep the 60 FPS and remain with the data there. Well, using React web workers and observables, this is kind of like easy, but it's not trivial. So I'm going to show you on this video how it works. Let's go. So first things first, the first thing that we're going to do is create the worker. Basically, I'm going to call this WS client, where we're going to process the WebSocket connection on the worker. It's off the main thread. And this is where we're going to do like our transformations, our calculations, and etc. So whenever this happens, it doesn't block the main thread. So whenever we transform the data, we're going to send it to the observable hook through post messages. Then it's going to go to this hook called use WebSocket client, where we're going to process the data and manage the worker. Then we will send this data to the observable through the use WebSocket data. So it gets the data from the observable and passes it down as a data object. Then we can consume it on the component that basically imports this use WebSocket data and gets data out of it. It's going to be easier when you see these items. So let's go to the code. So this is the structure. It has basically the use WebSocket client, use the WebSocket data, and the WebSocket client here on the workers folder. The way that I'm handling the workers here is with Comlink, and I'm using Comlink here to expose the worker to the main thread. So basically here, this part is very simple. It only has the WebSocket client class that has the connections mapped. It has the reconnection interval and it has a should reconnect. This is for reconnection if the WebSocket gets disconnected by network or something like this. Then on the connect, I basically I check if the connection was established already. If not, then I create the WebSocket. And then on message, I'm doing this calculation here, this for loop, just to pretend that I'm doing some transformation with the data. And then on close, I'm going to delete it and reconnect, depending if I want to reconnect or not. And on error, doing the same thing. And then here I'm setting the connection and should reconnect to true. And then here on reconnect, I'm reconnecting, basically checking if the channel should be reconnected or not and using the reconnect interval. On a disconnect, I am doing this, getting the connection, and if the WebSocket exists, I'm setting the should reconnect as false and closing it and deleting it from the list of connections. And then this is basically to send a message to the WebSocket channel if I want to do like a communication side of things. It's basically like getting the WebSocket connection and then sending the message if the WebSocket is ready and open. And then I expose it, and I'm also exporting the type because I'm going to use it on the WebSocket data, on the WebSocket client, sorry. WebSocket client basically creates the worker, and as I'm using Next.js, I have to check if the window is undefined. If the window is undefined, then I'm not going to create the worker because I only create it on the client side. Then I will return the worker here. And this is a basic way of generating a worker with Comlink. So I'm going to get the worker here, import it as a module, and then as I create it, I'm going to wrap it with Comlink here and generate a type for it. And again, I'm going to check if the worker exists. Otherwise, I'm going to go to null. This is the typing. And then on the use WebSocket client, I'm going to basically again, check if the worker exists, if the WebSocket client exists, and if the window is not undefined. Otherwise, I'm going to basically send an no-op functions to it. Then I'm going to set up the observable. Observables have this $sign in the end usually. And the way to create the observer is the observer has two ways of receiving data that I'm going to use on this case. That is the subscriber, that's the first parameter here. Then I'm going to connect, and if it's an error, I'm going to throw an error to the observable, so the observable knows that an error occurred. Then I'm going to create a listener. This is going to be passed to the event listener here. And also, just FYI, on the return of this observable, I'm going to clean up to disconnect it and to remove the listener. So whenever I remove this hook or this part of the code from the page or whatever, I remove it from the rendering process, this is going to remove the worker and the WebSocket connection from the threads. Basically, the listener here, we get the data in the channel from the event data that was posted. Remember, whenever we receive a message here on this onMessage, I send it to the WebSocket client. So here I receive it and I check if the channel is the same. This is important because other like extensions, for example, they send messages through post messages. So you have to check if the channel is the same. And it's also good because you can have like multiple channels listening into the same WebSocket connection. So you can have like one endpoint with many channels listening to it and many like hooks listening to it. This is a very like a specific thing for this case. Every WebSocket client has a different way of handling it. In this case, if I receive data that is called ping frame, I'm going to send back a pong frame and return it. Then I'm going to parse the data. And the parsing here is basically like a way to getting the data as an object. And then I'm going to check if the data contains a code and an error. If it's the case, then I'm going to throw the error and alert the observable about it. Otherwise, I'm going to send the data to the subscriber with this subscriber.next. This is the only case where we send the data. And then here, I'll add the event listener that basically on every message from the worker, I'm going to run this listener and then I'll remove it. Then I have, of course, the send function that is a simple, as soon as I receive a message here, I send it to the client and that's it. Then on the use WebSocket data, I basically instantiate the observable in the send from the use WebSocket client. And I get the data from this hook, the use observable state. That is a very nice way of handling observables in React. It transforms the observables in hooks. I'm here passing the use of observable state. The first parameter is a function that returns the observable. And the second parameter is null because the second parameter in this case is the initial state, and I don't want any initial state for this case. If I wanted, I would pass like a initial state here, st. That is the thing that I want here, and then here I would pass initial state. That's actually a good idea. Let's do it. Then, and to be honest, I don't want this initial state to be like this, so I'm going to instantiate it as null. And it says that it has a question mark in initializer, so I'm going to just remove this and saying that t is not initialized as this, so I'm going to not do it right now. You can do it on your own and post on the comments how you did it. All right, so then you see here that I'm exposing the data and the send to the hook. And on the page, I'm simply instantiating it with the endpoint that I'm using. I'm using this endpoint from Binance that has this data type. I got this data type from the docs. And I'm using two here just to show off how it works. And then I'm just showing it on the screen with a JSON stringify. I also created another page that shows how we would handle the WebSocket connection entirely on the client, on the main thread, using a very similar hook, but everything on the main thread, and doing the same calculation that I'm doing on the WebSocket client worker. So yeah, let me show you how it works on both pages, and let me show you the FPS on each one of them so you see the difference between the slow and the fast one. As you can see here, this is the fast page and this is the slow page. This one is dropping a lot on the 60 FPS because it's doing the for loop on the main thread. Whenever it goes into more calculations, as you can see, like there's even a loading sometimes happening. When there are many updates per second, it kind of like freezes the page. And on this one, it doesn't happen because it's doing the calculations and all the processing off the main thread. So it's way faster. So on an application where the 60 FPS matters, like on a high frequency exchange, or when a data visualization requires like a real time visualizer, then this is a very important technique to use. All this code is going to be open source, so you can see it on the description of this video and you can tweak it the way you want. So this sums up like the entire thing. As I said, it's a very niche thing. It's only important if you have like this set of things that you have to do, like you have a WebSocket connection or some sort of like update that happens many times per second and you have to do some transformations on it. So you have to take it out of the main thread and you have to keep the 60 FPS or 120 depending on your application on the screen. If that's not the case, then you can use it directly on the main thread. It's not going to be like a huge deal, but it is important to know. I hope you like this video and see you in the next one. Bye bye.